All right, in this video, we're going to talk about the similarity and differences between entropy and enthalpy. Well, to cut to the chase, they're not related. There's no connection between them. But if you watch this video, I'll help show you where students get confused between the differences. So we're just going to spend a few minutes talking about what each one is and the differences, ask some questions that students typically get confused on, and how we can sort through all of that. I'm Dr. Ryan Hayes from Andrews University. Glad you have joined me. Hopefully we can learn a few things about the chemical world around us. What is enthalpy? Enthalpy is about heat. Is heat being generated by the chemical reaction? Does the heat pull in? Is it hot to the touch? Is it cold to the touch? Does the thermometer go up? Does the thermometer go down? We talk about heat and what's going on. Exothermic, endothermic, these are the terms when we're trying to understand about the enthalpy, delta H, the letter that we use with that. Entropy, we don't talk about heat. We talk about is the system expanding, contracting, going from a solid to a liquid to a gas, where the distances between the atoms are changing. Are we creating and comparing molecules that have different arrangements to them? Is something spreading out, like mixing or dissolving, or is it coming together and freezing or precipitating? So these things, this is how we think about entropy, expanding, contracting. Entropy is pushing molecules to be apart and atoms to be apart. Okay, so you can see I'm already talking about two different differences. How do students typically perform and understand some of the questions that we like to ask about this? So here's one. For which process is the entropy of the system positive? And give you some questions there to look at, A through E. And then we'll do a follow-up with this question. For an exothermic reaction, what is the sign of delta S? So you can look through those. I'm going to pause for a second so you can answer them. Okay, now hopefully you've had a chance to look through them. You can pause the video and see the question and the answers in more detail. All right, so what's the answer? Well, for number A, the answer was, there's two answers, A and D. Both ammonium chloride here is dissolving and sodium chloride, they're dissolving. So the key terms are dissolving there. So we want to look for that. Okay, so I'm gonna see if I can highlight them here. Get my laser pointer. Oh, there we go. Dissolving and dissolving. And so that's why A and D is the best answer. And then, so we picked that. How about for an exothermic reaction? What is the sign of delta S? Well, you can't tell. Well, why can't you tell? Why? What's the difference going on there? All right, so what have students answered in the past? Well, in the past, you can see here in 2017, question 1, 2020, here I just did it recently with my class. A good majority of them picked E, and if they didn't pick E, they picked A and D, which are good answers as well, and nobody picked B and C this year. And then, but in previous years, we've got a few students to select it. So that one seems to be pretty straightforward for the way that we're teaching it and for how students are answering it. So that's great. However, the wheels come off the cart here in question 2. And we did get a majority of our students now who made the connection, but that's quite a few students here. Over, about 45% this year, and in previous years, and as much as 78% who couldn't tell the difference, with C being the correct answer there. Here's another question that typically I like to ask, and I'd like to see if students can answer. What is the sign of the entropy for evaporation? Positive, negative, or 0. Okay, now what's the sign of the enthalpy for the evaporation? I'll give you a moment to think about it. All right, hopefully you've paused the video and thought about it for a second. What are the answers? Well, for the entropy, it's positive. You're taking a liquid, which the molecules and atoms are close to each other, and then gas, they're spread apart. What about the enthalpy of the system? What did you pick? Well, hopefully you picked positive, because it's an endothermic reaction. You have to put heat in to boil water to make it evaporate. Heat has to go in so they have enough energy to get into the gaseous phase. So if you're not convinced, think about what does it take to boil water? And I think you'd understand you have to create heat somewhere and then put that into the water. Now, over the years, here's what students have answered. Question 1, no problem here in 2016 or 2020. Majority of students got that one. There's just some confusion on enthalpy. And we talked about enthalpy last semester. We've been talking about this semester. And somehow bringing up the concept of entropy just confuses everybody. And so thankfully, though, we had a majority here this year who answered it correctly, but it was all messed up a few years ago. So I usually see somewhere between these two percentages. So what's going on? Students are not understanding that there is not a connection between the enthalpy of the system. I just think about heat. Is heat going in, heat coming out. And so you can use a thermometer to tell the difference. And then for entropy, I just ask a different question. Is the system coming apart or is it coming together, like billiard balls? So expanding or contracting, dissolving, mixing, precipitating, that's how we think about what's happening to the atoms there. Completely different questions. They're not related to each other. They are not dependent on each other at all. And hopefully you're getting the sense that we're asking different questions when we're trying to answer those aspects of a chemical reaction. So there are 4 different types of chemical reactions that can occur based on the 4 different variations that you can have. So entropy could be spreading out and be positive, but you could have enthalpy be positive or negative. It doesn't matter. Certain reactions just fall into these 2 different types. So here, the dissolving of ammonium nitrate, very endothermic reaction, but it's spreading out. So it happens, it takes place. And so this is under that first category here. This other category, when you dissolve calcium chloride, it's very exothermic, it's hot to the touch. So we have a difference here. They're both spreading out. We have the very wonderful reaction of hydrogen and oxygen reacting to make water, but you have 3 molecules in the reactants to form 2 molecules of the product. So this is a contracting system, but it's very exothermic. I use this to pop balloons in class and for demonstrations. It's a lot of fun. Definitely gives off heat and energy. When you take something like the overall photosynthetic reaction scheme, which is endothermic, you got to put energy into it to make this reaction happen. And you're taking 12 molecules and generating 7. So this is a contracting system. So these are examples of the 4 different types. So if you're looking for a relationship, whether it's positive, entropy, what is enthalpy, you don't know until you look at the chemical reaction and what's going on with its heat. Okay, no correlation. You have to ask different questions about that. So that's why these 4 end up in different quadrants for me when I talk about Gibbs free energy and the entropy of the universe right here. So these are the 4 different ways to think about it. Where do students get confused? Well, it's really when they get asked questions like this, when they're deriving Gibbs free energy and the entropy in the universe, we have to think about the entropy of the surroundings. So what's for an exothermic reaction, what is the entropy of the surroundings? So the key thing here now is the subscript. When we're defining these things, this is where the problem comes in. See, for this is positive, and I bet a lot of you wanted to answer, can't tell. Well, no, you definitely can tell for the entropy of the surroundings because there's a definition that says that we can replace the entropy of the surroundings with the enthalpy, the negative enthalpy of the system divided by the absolute temperature, which is what we do in the Kelvin scale. So this is on a whole nother video about entropy and entropy of the universe, how we think about those things. And so the surroundings then is a replacement of the enthalpy. So this is where I think students get confused when they see that, but we're specific and you can see the subscripts as surrounding. The other place that students think there's a connection is when you're talking about a spontaneous chemical reaction, and as it goes from being spontaneous to non-spontaneous, it crosses over a spontaneity of 0 for the universe, or the Gibbs free energy is 0, and we can solve an equation to help us determine the temperature at which this transformation takes place. And so it looks like there's a connection between enthalpy and entropy in here. That's only because of us solving the second law thermodynamic equation. So in summary, they're not related. Entropy and enthalpy, we ask 2 different questions and we think of them separately. They're definitely forces that we need to be keeping track about for chemical reactions. We have calculations for each. They're very similar in how we do that. And it's important to know that all chemical reactions, when we study them, fall into the 4 different types as we see with the entropy and enthalpy. Hopefully you learned a few things in this video about the differences and similarities between entropy and enthalpy, and that you'll be able to better appreciate chemical reactions in the chemical world all around you.